Hello everyone. This video is on the Knewton Alta assignment for section 3.2 part 2 called Simple Interest and Discounts. So in this video I'm going to be going over a preview version of this assignment. So please understand that the questions I see in this video may not be the same questions that you see when you work on the assignment yourself. But all the objectives are the same, the structure is similar, so I'm hoping that watching me do these here helps you out when you work on it on your own. Alright, so your assignment page, you should be seeing the title, the mastery bar, right, telling you how far along you've gotten. The objectives, looks like there are only 2 objectives in this particular assignment. Under the current objective, there should be a question related to that objective. And at the bottom of every question, you should be seeing a feedback button. You can send feedback to Knewton if you wish. You will not have this instructor cheat button. Right, that's for instructors only. But you will have a more instruction button. So if you're ever struggling with a topic, click on this and you'll be taken to a page with some reading or some videos to study. And you'll be given questions related to that instruction, and completing those questions is another way to progress through the assignment. Okay, so the first objective I'm seeing is solve applications with discount or markup. So discount just means you're taking off from the original price, you're taking away a certain amount. Markup means you're adding to the original amount, you're increasing the value, increasing the price. And this question is about a markup. So Daria bought a bracelet at original cost $16 to sell in her handicraft store. She marked the price up 45%. So what is the amount of markup? Right? Markup, how much did she increase the cost for her store? Okay, so the original cost of this bracelet is $16. That's what she paid for it. Well, then she bumped that up by 45%. Right, so the markup is 45% of $16. Right, so that's just a multiplication problem here, right? 0.45 times 16. And I've just got a calculator off to the side. You could do that by hand as well, but just to speed things up a bit here. 0.45 times 16. This is 7.2, or $7.20. And this is what they're asking for. That's the markup. That's how much she increases the original cost. So that's what they want. But if for some reason they asked you for the new cost, right, the new cost would just be the original cost plus the markup. So it would be, you take $16 and add 45% of it. Add this $7.20. This would be $23.20, right? So in her store, she bought this bracelet for $16. In her store, she's selling it for $23.20. Right? That's a markup of $7.20. That's that way she can make a profit, right? If she bought it for $16 and sold it for $16, she wouldn't be making any money at her store. But the markup is all they wanted, right? And they have the dollar symbol already. I'm just putting $7.20, right? $7.20. All right, and then if they ever ask about a discount, that's going to involve subtraction. It's the same as markup. If she discounted it 45%, then she would subtract the $7.20 from the original cost. All right, next. All right, so same objective still. This time, though, we have a discount. So this will involve taking off the original price, lowering the original price. So Nikki bought a patio set on sale for $480. The original price was $850. What was the rate of discount? Round your answer to the nearest tenth of a percent. All right, so this is basically like in section 3.2 part 1, we discussed percent increase and percent decrease. Markup is a percent increase. Discount, you have a percent decrease. All right, so this problem here, again, the original price was $850. The new price, the discount price, is smaller, right, $480, and they're asking, what's the discount? What was the rate of discount? What percentage discount was there? So, I mean, here's how that would work. You take the original price, $850, and then you would subtract, whatever the discount rate is times $850. Right? They'd multiply $850 by some discount percentage, and then take it away from $850, and this is equal to $480. Right? That gives me the discount price. Now, instead of writing discount rate all the time, I'm just going to call this D for discount rate, and we're going to solve this equation for D. So I'm going to subtract 850 from both sides, so we have negative, 850 times D, right? D times 850, negative 850 times D equals, now 480 minus 850, that'd be 370, negative 370. 480 minus 850, and then divide both sides by negative 850, we get D equals, positive 370 divided by 850. Negative divided by negative is positive. And remember, this is how we calculated percent decrease. You had the difference in the original price and new price, 370, divided by the original price. This is the same thing as calculating percent decrease, if you remember that from section 3.2 part 1. Right, so again, there's a percent decrease when you're talking discount. There's a percent increase when you're talking markup. Now I punch this into a calculator. Now you don't need the zeros, they can cancel the tens, but this is the same thing as 37 divided by 85. And this number is equal to 0.4352 whatever. But as a percentage, right, they want us to write this as a percentage. So I multiply by 100, make this 43.52 whatever, and then divide by 100, right? Multiply by 100, divide by 100. But the dividing by 100 is percent, right? So I write the percent symbol. And then we're asked to round this to the nearest tenth of a percent, which would be 43.5. Right? That'd be the nearest tenth of a percent. So there's your discount. So the original price was $850, and then they discounted it 43.5%. Right? You took 43.5% of $850 and subtracted it, and got the this discounted price of $480. But it's just a percent decrease for 43.5% approximately. Oh, and I forgot to mention this earlier, right? Whenever you submit an answer, it'll tell you if you're right or wrong, and then it'll give you some sort of answer explanation. Right? Please read through these, just to make sure you understand why something was right or why something was wrong, especially. And then hopefully you can learn from your mistakes for future questions. Alright, the other objective here is solve applications involving the simple interest formula. Alright, so first I'll write out the simple interest formula for you, explain what the parts of it mean. So, simple interest formula. Alright, so interest, you may have heard the word interest before, especially if you deal with loans or credit cards or mortgages. Interest is basically like a fee for holding on to money for someone. You know, when you take out a loan, you pay it back with interest. You know, or you might have heard, you give a bank money, you put money into a savings account, and the account earns interest. You know, they're paying you basically a fee for holding on to your money. So yeah, but now simple interest is basically the same amount of interest, the same fee is applied for every period, every year. Right? Here's the formula. I equals P times R times T, or just PRT. Right? Now what do all these letters mean? The capital P there, this is what's called the principal, and sometimes I've also seen it referred to as the present value of the account. Basically the initial amount, the amount that you have in the account at this moment, the principal amount, the initial investment, whatever. R is the annual percentage interest rate. The annual percentage rate, which you may have seen as APR. This might look familiar. APR. I'm sure you've heard the term APR if you've ever dealt with credit cards. This is the interest rate. They also call this the interest rate or nominal interest rate. Just nominal rate. APR. Right. Now this will be given as a percentage, but remember what percent means. It means divided by 100. So you should be writing this as its actual value in decimal form. T represents, time. And when you're dealing with money problems, it's time in years. Right. And then I, you might have guessed, represents the amount of interest earned. This is the interest earned after T years. I'll just say interest earned. Okay. So interest equals principal times interest rate, or APR, or rate, times time. And then if you put this together with the amount that you currently have in, that principal amount, the amount that an account is worth, or that you owe on a loan or whatever, the amount after T years is equal to the principal amount, right? The amount you currently have, the present value, plus interest. So in other words, you'll see this formula pop up sometimes. So the amount in an account is equal to the principal plus, now the interest is, PRT. When you're talking simple interest, when the same amount of interest is added every single year. All right, so you see this formula pop up on occasion as well when talking simple interest. All right, so now that I've got all these letters popped out there, I'll tell you what they mean. Let's go back to the problem. So here it says, Jamie's refrigerator loan statement said that he would pay $1,026 as interest after 4 years at an interest rate of 13.5%. So how much did Jamie borrow to buy the refrigerator? Right, so what was the principal? So they gave us here, they gave us the amount of interest paid. Right, interest is $1,026. They give us the time in years, 4 years. They give us the interest rate, 13.5%, which we're going to write as 0.135, right? Write it as a decimal. So we only don't know the principal, right? The initial amount, the initial amount borrowed here. Right, so I've got the formula up still. Let's do that. Like I said, we're given everything but P. We know that the interest that he's paying back is $1,026. The interest rate is 13.5%. Again, remember percent means divided by 100, so that means I'm writing this as 0.135, right? Use the decimal version. Don't use 13.5. It's 13.5% divided by 100. The time is 4 years. We just need to find that principal, that initial amount borrowed. So I pop all this stuff in. So 1,026 on the left equals, P times 0.135 times 4. Okay. Now if you multiply these, again I have a little, you can use a calculator or by hand or whatever. 4 times 0.135. So this is 0.54p over here, 0.54. That's 4 times 0.135. And then times p equals 1,026. Right, and then to get p alone, to solve for that initial amount borrowed, solve for that principal, I need to just divide by 0.54. Right? So the principal is 1,026 divided by 0.54. And let's calculate that. Again, I have a calculator in my hand. Divided by 0.54. And this is a nice whole number actually. This is $1,900, right? Principal should be a dollar amount. So there's the initial amount this person borrowed. Right? If they were paying $1,026 in interest after 4 years at this interest rate, this is the amount they must have borrowed then, $1,900. And then I'm going back to the assignment, and that's what I'm entering, 1900. Great. And again, please read through the answer explanations. All right, so another simple interest formula problem. So it's very much the same thing, but instead of a refrigerator, it's a car. Right, Margaret's car loan statement said that she would pay $7,683.20 in interest, right? So that's the interest. That's going to be the value of I for a 5-year loan. So T is 5 at an interest rate of 9.8%. So R is 9.8% or 0.098. So assuming this is an example of simple interest, how much did Margaret borrow to buy the car? So again, we're solving for P, right? That principal, that initial amount borrowed. So back to the formula again. Now we're told the interest paid is going to be $7,683.20. That's the value of I. P we do not know. R was 9.8% or 0.098. Right, write it as a decimal. Not 9.8, but 9.8% divided by 100. times, and then T they told us was 5 years. It was a 5-year loan. Okay, and then so like last time, I'll multiply these two numbers to get the coefficient of P. 5 times 0.098. Multiplying these two gives me 0.49. Which again, I probably could have done without a calculator, but whatever. And then we would just simply divide by 0.49. So the principal, that initial amount borrowed, is going to be $7,683.20 divided by 0.49. So let's do this here. 7,683.20 divided by 0.49, and it's a nice whole number again. This is $15,680. That was the initial amount borrowed. If you're paying that much interest over 5 years with that interest rate, 15,680. And that's what I'm putting. Okay. All right, next. So back to the discount or markup, percent decrease, percent increase problems. All right, so Flora paid her supplier 75 cents or $0.75 a stem for roses to sell at her flower shop. She added an 80% markup. So again, what is the amount of the markup? It's just 80% of 0.75. Right. So yeah, so the markup here is simply 80%, which is 0.8 of the $0.75. Right. So multiply those. 0.8 times 0.75, that's 0.6 dollars, right, or 60 cents, but they want it in dollars, right? 0.60. 80% of 75 cents is 60 cents. So this is the markup, right? This is the markup of 80%. So the new price, if they aren't asking for that, but you would take the 75 cents and add this on to make it 135 cents or $1. Should be selling these stems of roses for $1.35 each. But they just want how much would she increase the price by, right? $0.60, 60 cents. Okay. All right, so it looks like we just got this one more with a discount or markup. So again, Bill found a book he wanted on sale for $20.80. The original price of the book was $32. What was the discount rate? Basically, what was the percent decrease, right? The original price was $32. They're selling it for $20.80. What's the percentage of the decrease? What's that discount rate? So again, pretty simple here. Just the discount rate is just the percent decrease, right? You take 30. The original price was 32. Take away $20.80, and then what percentage of the original price was that, right? And we're going to change it to a percentage, right? We saw this in section 3.2, part 1, right? Percentage decrease. So this here is 20 cents, $11.20 difference, right? That's how much the price was decreased. $11.20, and then what percentage of 32 is that? Right. So $11.20, divided by 32. This is 35%. It's 0.35, which, if you change that to a percentage, is 35%. So there was a 35% discount, right? You take $32, multiply it by 35%, and then subtract that, right? they're just asking for that, percentage, 35% discount. Great. All right, next question. Now we're just back to the interest problems, simple interest formula. So here in 25 years, so they give us the value of T is 25. A bond with 4.75% annual interest rate, that's the R, right? And I'm going to write that as 0.0475, right? Write that as a decimal. Earned $2,375 as interest. So again, we have the interest. What was the principal amount? So again, we're solving for P. So again, the formula once again, interest earned equals principal times rate times time. That's simple interest. You'll learn about compound interest later in your math studies, but that's not happening now. So the interest earned, they said, was $2,375. That's I. We don't know P. The interest rate was 4.75%, which would be as a decimal 0.0475 times, and then the time was 25 years. So once again, I'll multiply these to get the coefficient of P. So 25 times 0.0475. So this is 1.1875 times P equals this 2,375, and then we divide, right? So P, and then I'm just going to take 2,375, let's do it on my calculator, 2,375 divided by 1.1875. Oh wow, I should have seen that. This is exactly 2,000. So if you take 2,375 divided by 1.1875, it's 2,000 even. So the principal amount of the bond was $2,000. Okay, so all these have been pretty similar so far. They may have some other problems where they give you the principal and the time and the interest, and they ask you for the rate. Or they'll give you 3 of these 4 letters and ask you for the 4th letter. It should be easy to solve. All right, should have just one more of these. Yeah, like I said here. What was the rate? Moira borrowed $4,500 from her grandfather to pay for her first year of college. 3 years later, she repaid the $4,500 along with an interest of $243. So we have the principal, $4,500. We have the time is 3 years, T is 3. We have the interest is $243. What was the interest rate? And round your answer to 1 decimal place, right, to the nearest tenth of a percent, right? Notice they have percent symbol here, so we have to change our result to a percentage. So let's do this over here. We have, the interest was $243. The principal was $4,500 times R times 3 years. So if I divide by 3, now you can multiply these and get a coefficient of R, but I'm going to do this. I'm going to divide by 3 first, get rid of the 3. That'll turn this side to 81 equals 4,500 R, and then divide by 4,500. Alright, and this one's not so bad, because we have R equals 81 divided by 4,500. Now 81 and 45, they share a factor of 9, right? 9 times 9 is 81. 9 times 5 is 45. So this is 9 over 500, which would be 18 over 1,000, which is 1.8 divided by 100. So 1.8%. Remember, percent means divided by 100. So 1.8% is the interest rate. Now again, you could have just punched in 81 divided by 4,500, and you would have gotten 0.018, and then change it to a percentage by moving the decimal place to the right twice, and that would be 1.8%. Right. So 1.8 is the interest rate, 1.8%. They already have the percent symbol there, so I'm just writing 1.8. Great. Alright, and that should be it for this preview version of this assignment. Now, like I said at the top of the video, the questions I saw here may not be the same questions that you see when you work on the assignment yourself, but the objectives are the same, the structure should be similar, so I'm hoping that watching me do these here helps you in some way when you're working on them on your own. And thank you very much for watching.